such diagrams. Let me keep spare. Yeah. No. One disk, it is given velocity u. Let me call O1, O2, and this is given angular velocity, omega naught. Let me call u naught. Later on, I'll change the symbol. Both are having same radius, r. Only it is given translatory motion. You can see that one. This is given translatory motion. I'll call this a disk 1. This is a disk 2. Now look at it. I think so many things are there here. Perfectly inelastic. Perfectly inelastic. Slipping between the disk seizes. Okay, yes, really given. What do you mean by that? Slipping seizes means initially there's a slipping. Why slipping will occur? Means is indirectly saying surface is frictionless, but there's a friction between what? Between the disk. So how means he's telling slipping seizes. No? Find the angular velocity of disk and the speed of their centers after the collision. So this one will go and collide. So what actually happens here? I think you see one more thing. Very beautiful part of the question is like it didn't say the perfectly rigid body. So what happened to this will go and collide, perfectly inelastic collision. So it will go and deform it, no slight deformation. Don't again don't draw a diagram. I don't know, some students sir undergo deformation. See, you want to learn here or you don't want to learn? Yeah, some students I don't know, like sir, E equal to 0 deformation. Nobody will undergo deformation of to that extent. So slight deformation. It'll be like it's circular, no? Maybe here the way that the point of contact, slight deformation will be there. That's what the E equal to 0 means here. And destructive mind should be avoided. Huh? Okay, let's come for this one. This will go and collide. And there's a stationary. Don't get considered. It is rotating about. It's not like rotating and moving. The disk D, again, don't get confused with this. Stationary vertical center means initially it is rotating about a certain axis, and that axis is what? Fixed. Axis is not moving. The axis is passing through O2. That axis is fixed. The axis is not moving. But the disk, both the disks are free to move and free to rotate. That's what it's saying. Find the angular velocity of the disk and the speed of their centers after the collision. Means both the disks are free to move. So then what do you mean by stationary? See, if it is rotating means I should call about rotating about an axis, and that axis is stationary. Axis is not moving, but the disk is free to move. Okay, this is what happens. So what all here you are having? Collision, conservation of linear momentum, friction will act, angular impulse, angular momentum equation, then all that one. So now it's telling E equal to 0. So all three mixed ideas we are bringing, and torque, everything we are going to introduce here. I think all of you write the question first so that I'll teach, because you'll understand. And now don't put rolling. I think read horizontal frictionless surface. They're lying. So it's simple. Two carom board coins. This coin is rotating and this coin is moving towards it, and they're kept on smooth horizontal surface. So don't draw like this. Sir, here rolling friction will act. Smooth horizontal frictionless surface. Horizontal frictionless floor. How the weight will act? Weight will act into the plane of paper, at least, fine. Okay, let's get into the problem. So they'll come and collide. Finally, what happens? The disk will come and collide, no? After collision, what will happen? So during that collision, what will happen is what we have to see here. I'll just magnify the diagram so that what all diagrams I'll show, no, it'll be easy for you. Let me take this. There's a center of the disk. No? Now, this will be O1 and O2. It'll go and collide, no? So slight deformation here, slight deformation here. So that they're in fact they're in contact. Yeah, slight deformation. Because you don't show deformation more. If you show deformation more, what will happen? Moment of inertia will become a problem. So slight deformation. I'm showing that strip and understood. Okay, for our understanding purpose. Okay, let's come for this one. What is the angular velocity of this? This was having angular velocity omega naught. The moment they come in contact. So what is the velocity of this point? And impulse will act first. And the impulse will act here like this. Then it was having angular velocity. So this was the omega 2. So then now the friction force here should act here. So mu F. And so this friction force will set up a torque, and because of that angular velocity decreases. Earlier it was omega naught, now it has become omega 2. Fine. Omega naught, now omega 2. Okay, keep it here now. And after this, how the friction will act on the disk 1. The disk 1. How the friction should act on the disk 2. On the disk 1 should be in this direction. Mu n, no? So some normal contact. And this friction, what happen, will set up a torque and it will make the disk 1 to acquire angular velocity omega 1. Will I agree this? Why omega 1, omega 2 should be like this? Okay, come for this one. Next again, this impulse J which is acting. So what it will do? It will make the disk to acquire a velocity like this. V2x. This friction force mu n which is acting will also act, will make it to move in this direction. Okay, are you getting this one? Why V2x? Because of this impulse. Or because of this normal contact, you can put it. Or if you're getting confusion, if you want, I'll write n into delta t will become impulse. This also impulsive friction will act. So let me show time being mu n only. Or fine, no problem. Anything? Okay, now because of that, what happens? This will acquire v1x because of this force. Because of this mu n delta t, this will acquire a velocity. So v1 y, so this will be v2x. What happens to this one? This impulse will act towards left, opposite to velocity u naught. So let it have velocity v1x. I think this is the preliminary thing which a student has to generate. Okay, let's get into the problem here now. Let's talk about the total system. What is the net force acting on this system? Along y-axis, mu n delta t, mu n delta, 0, no? So therefore, what should be the net force acting on system along y-axis? 0. So therefore, momentum must be considered of total system. What was the initial momentum along y-axis? 0. Final momentum. And both the disks are having same mass and same radius. So what you can say about V2y and V1y must be equal. So I'm talking about the system. So now you will write the equations here. Let both the disk be the system. Then net force along y-axis 0. So net impulse is 0. So because of that, what happened? Initial momentum should be equal to final momentum. Initially, what was the momentum? You say this is initial. And so call this is a sum final. Or I'll give one more diagram. Finally, what will happen? Will they be in contact like this only for all the time? Now this again, your physics should be brought into the picture. Will there be contact like this for all the time? If you say yes, then I cannot help you. I'm telling this one. I'm very frankly, I want to speak. If you say, sir, they'll be in contact with all the time, means then nobody can help you in this aspect. Finally, what will happen? Will they lose contact or they'll be in contact like this for all the time? Look at the velocities. At least bring the idea of laws of motion. You know many things. Finally, will they be in contact like this for forever? Because sir, E equal to zero. Who said that E equal to zero? They must be in contact. It's a two-dimensional collision because of the v2y and v2x. It will move like this, no? Because of v1x, v1y, it will move like this. So what do you expect finally? They lose contact, no? So finally, what happened? I see that this is having omega 1, omega 2. This is having the same diagram. I just shown there. They will lose contact finally. When they're about to lose contact, that's what we say final. This is a final. This is an intermediate diagram at any time t. You can say like. So I think we have everything. So let's write conservation of linear momentum. So what is the initial momentum along y-axis? 0. Final momentum m v1y m v2y. So finally, what do I get? v1y equal to v2y equal to vy along x-axis. Along x-axis, so I can write initial momentum. So I'll proceed like this here. Let me write impulse equation because I could have written directly. So let me write in terms of impulse so that you will get a basic idea of that one. Or sir, can I apply conservation of momentum along x-axis also? Yes. What was the initial momentum? Mu naught. And what is the final momentum? What is the final momentum? So let me proceed in this way. And now let both the disks be the system. I think this is something I'm revolving in. So initial momentum mu, final momentum m v1x plus m v2x. Okay, what about v1x and v2x? We don't know that. So let me analyze individually. That's what the problem. Both are unknowns are there. So what shall we do? On disk 1, mu minus j equal to mv1x. On disk 2, j equal to mv2x. Will I agree this? Okay, again you add up. What do you get? The same equation, no? The same equation. So let's get into the collision concept. Huh? You have to bring the collision idea now. E equal to 0 is telling, perfectly inelastic. So I think it doesn't much, not helping us. If you, okay, I just shown this. But if you add up this to again, we'll end up this equation. Let's bring it to the collision as E equal to 0. Tell me what will happen. Final happen. Both what happen will undergo say maximum deformation. At maximum deformation happen. Both must have common velocity. According to collisions, as E equal to 0, v1x must be equal to v2x. Let me call vx. Because of E equal to 0, I'm able to write. Otherwise, not possible. Agree this? Why v1x must be equal to v2x? Because E equal to 0. Sir, like still we are not getting. See, like actually, that this one will go and collide. They'll undergo maximum deformation, and at maximum deformation, both must have common velocity. Agree this? And in inelastic collision, what happen? Both will have common velocity. That's what it is. So therefore, from that, I'll substitute mu is equal to m v1x plus m v1x. So therefore, what is v1x equal to? U by 2. I think also what is v1y? I think there's a one very best equation is what we have generated just with the help of collision idea. Without this, not possible. Huh? I just highlight it. And this is one something conservation of momentum here. Huh? There's a one picture. So, but they are rotating, they are colliding, impulse is acting, angular momentum, angular impulse is acting. Let it be. We are just talking about the collision phenomena here. That's what this question. Okay, now after this, what was our main question? We have to find out the velocity v1x, v2x, v1y, v2y, and what is the final angular velocity. That's all our question. Let's get into the finally what happened. There's a point P1, this P2. So velocity of this point will be Vp1. Now look at this. Again, I'll go back to the question. If the collision is perfectly inelastic and slipping between the disc ceases in the end of collision, I think for why you are writing equation, because the question given that condition, I'm writing it. If the collision is perfectly inelastic and slipping between the disc ceases in the end of collision, means the moment both will acquire common velocity, at that instant what happen? Vp1 will become equal to Vp2. You should not blame me, sir, like why you are writing the equation, because the question condition is given. So when the slipping ceases, the moment what will happen, the collision is about to end, the slipping ceases. So when V1x equal to V2x, then Vp1 equal to Vp2. Condition is given. So according to given condition, most of everything fine, Mark. Just listen. No need of doubt. Huh? Please do listen. Huh? As condition given in question, so Vp1 equal to Vp2. Now, what is Vp1? What is Vp1? In the end, you can ask it. Let me finish off this one. What is Vp1 is equal to? Look at this. It is having tangential velocity and also what pen V1y, no? So Vp1, what we can write it as? Vp1 should be equal to V1y plus R omega 1. Let me write here. Vp1 is equal to V1y plus R omega. What is Vp2? Vp2 should be equal to R omega 2 minus V2y. Why we are writing in this way, this equation? Because the body is having both the disk 1 and 2, both are having rotating as well as translating motion. So what is V1y should be equal, Vp1 should be equal to V1y plus R omega 1. Vp2 is what? R omega 2 minus V2y. V1y is equal to V2y. From where? From here. So therefore this should be what? Vy R omega 2 minus Vy. So 2Vy equal to R omega 2 minus omega 1. There's one more. The equation is what we have. After this, what is omega 2, omega 1 is unknown, no? From where to bring other equations? I'll go for, I'll look at the diagram. Let's look at the final diagram. So let me define one point. They're in contact. In fact, they're in contact. Just about to lose contact. This one. Shall we define the angular momentum? And okay, then I'll do one thing. I can paste diagrams, no? Yeah. Now I'm bringing the conservation of angular momentum. So initially, just before this two, this is this one. Now look at this, and this is that point P. What was the initial angular momentum? About point P. So what is that? Looking at these two diagrams, this is the initial and this is a final. No, LPZI. But sir, like a friction will act, okay, but it will intersect axis of rotation. The moment they come and they collide, no, so what will happen? Friction will act here. Of course, the friction will be equal and opposite. Go back again here also. The first diagram, very first, mu n delta t, mu n delta t. Impulsive friction is acting. J is also acting. So if what is the point P? Point P is here. Point P is here. Exactly on that black dot, like a strip what I put, no, exactly at the midpoint of that one. So look at the what is the net impulse? 0. What is the net, this one, torque, impulsive torque? That is also 0. Angular impulse also 0. So therefore, angular momentum is conserved of the system of the two disk about this one, LPZI of the two disk. Not individual disk, of the total, everything. What is initial angular momentum? Looking at this, what you can see, this U naught will intersect axis of rotation. This U naught intersects axis of rotation. So therefore, angular momentum will be only due to this it will come, and how much it should be equal to IO to omega naught. And there's no translatory motion for the disk to keep it here. But select it is passing through point P and you are writing O2, but you should write IPZ. What is LPZI? Should be equal to angular momentum due to translating motion plus angular momentum due to rotating motion about center of mass. There's no translating motion. So only due to rotational motion, how much? IO2 omega naught. And what is the sense of this? Like this. This is the initial angle, this much on. What about, sir, why there is no angular momentum due to U naught? That U naught will intersect axis of rotation. This is for disk 2 and this one will be 0. Finally, let's write equation. What's happening to this 2? It is having translatory motion. Is it having any translatory motion? Yes, due to like a V2y. So how much it should be? Minus M2y, shall I write, or plus M2y? Minus M2y. Initial angle. I'll give the directions, okay? MV2y R, small r. And then due to rotating motion, IO2 omega 2. This is for this 2 plus this one will be M V1y small r. What about that angular momentum? Will be like this. Now look at carefully the diagrams, what all I give. Is it okay? So you stand here and curl it. Curl your fingers. So anti-clockwise, I'll take positive. Clockwise, let me take negative, that one. Clockwise, I'll take negative. So this will be what is I naught, and we know I naught 1 as they are identical, mr square by 2. Let me substitute all. Mr square by 2 omega naught is equal to m, I think this is Vy minus mr square by 2 omega 2. This is also anti-clockwise, no? So then this will be m Vy r anti-clockwise. This will be negative omega 1. Omega 1, omega 2 are different. V1y is equal to V2y. Just now we have shown it, no? Solving this, what we'll get? We'll get expression for relation between omega 2 and, so I think if I solve this one, anybody value? But we don't know omega 1, omega 2. I think omega 2, omega 1 and Vy is there. So how many unknowns are there? Omega 2, I'll list out. Okay, this one here. Anybody just solve it. Huh? If you tell me that equation, I'll proceed further. MVY to MVYR, and MR you can take outside. Okay, I'll do one thing. I'll simplify. None of you are responding. R omega naught to 2VY 2Vy plus R by 2 omega 2 minus omega 1. So let's do one thing. Give equations 1 and 2. What is value of omega 2 minus omega 1? Value is how much? 2Vy by R. That you substitute here. Solve it. You'll get Vy in terms of V naught. So put 1 into, at least anybody, value of this? Vy and omega naught are? Omega 2 minus omega 1, right? 2Vy by R. Okay, this one. Yeah. R omega naught by 6. Okay, thank you. Keep equation 3. Okay, something, what happened? I got Vy. So what is needed now? Vx is needed, no? Something Vx is needed, and Vx already we know. It is equal to how much? Vy we got it. And Vx is what? Already V1x equal to U by 2. Look at this. So Vx we know. Now what happened? We brought Vy. Now what is next needed? Omega 1 and omega 2. How to bring omega 1, omega 2? We need lot of some space here. I'll finish off that one. Okay, almost we are at the end of the problem. Anybody after this? Omega 1 and omega 2. So let's go for on individual disk, the angular momentum on individual disk, angular impulse. So what is initial angular momentum on the disk 2? I'll write it. Disk 2. Initial angular momentum I naught to omega naught minus an impulse will act J into R. Some impulse, or let's not bother that one. And finally what happened? It will become I naught to omega 2. Then similarly, an impulse will act on what? So this is what? On disk 2. This is on. So, but we don't know that impulse. Let's not, but what all that angular impulse act will be equal and opposite. I think I gave symbol J theta. Can you remember? So the entire problem here is what happened. You are trying to find out some things which are not needed. So there's some impulse, angular impulse. We are not bothered that, sir, we don't know mu, we don't know that n, we don't know that time. But at least, shall I say, that angular impulse is what? There is some angular impulse, and that angular impulse acting on the disk 1 and 2 are equal and opposite. Will I agree? Think logically. This impulse acting will set up a torque. This impulse acting will set up a torque. So angular impulse will act here. So it will decrease angular velocity of this. It will increase angular velocity of this. That angular impulse, angular momentum equation. I know, I don't know that J theta. We don't know J theta, write it. J theta unknown. No problem. We can eliminate. So I naught mr square by 2 omega naught minus, I'll add up one step. I naught omega 1 equal to I naught omega 2. I think this moment of inertia will get eliminated. So what is omega naught equal to? We'll get omega 1 plus omega 2. This is equation 4. Do we have any relation between this one? Omega 2 minus omega 1. So shall we take help of equation 1, 3 and I'll substitute in where? In 4. Omega naught, what we can write? 6 Vy by R. And what is Vy equal to R omega 2 minus omega 1? Solving that will get the required answer. I'll write all the steps once again. So as we know, 2 Vy are equal to omega 2 minus omega 1. Now Vy is how much? Omega naught R by 6. Small r. So here omega naught by 3 equal to omega 2 minus omega 1. Call this equation 5. 4 and 5. Solving it, we'll get omega 2 equal to 2 omega naught by 3 and omega 1 equal to omega naught by 3. Okay, fine. So finally, what will happen? We know angular velocities, we know linear velocities also. So this is our answer. So what is the velocity of the one, this one, what you should write? Should be Vx square plus Vy square. I think there's a velocity of the speed of each disk. And what is the angular velocity? We know it. And what is Vx square? U square by 2. And what is Vy? Vy is something we brought like this, R omega naught by 6. Final answer, I'll write it. You can check later on. Omega naught by 3. This is what in the books they're given. This will be the speed of each of the disk. This will be final. I took 1 by 2 outside. At the end of the collision, V1x must be equal to V1y. I think long back we have discussed, no? This one. Okay, later on you see, I think if you put one more effort, all this one, because problem has become lengthy. Okay, let's come to the other set of problems. These are, okay, that I just pick up those problems that will help us a lot to learn so many ideas, you see. System, disk, two disk if take system. Like this, you can also think, nothing wrong. Okay, come to the question now. Read the question. Meanwhile, I'll have water.